In the previous lecture, we have seen about expression for potential energy. Now, this potential energy, or we can say as change in potential energy, delta U can be written as 1 upon 4 pi epsilon naught Q1 Q2 upon R. So, this change in potential energy is nothing but the potential energy at a distance of R can be written as 1 upon 4 pi epsilon naught Q1 Q2 upon R. This unit of this potential energy is nothing but the joule. That is the name of scientist. So this 1 joule of this potential energy can be defined as the amount of work done in bringing 1 coulomb of charge through a potential difference of 1 volt. So whenever a charge of 1 coulomb will be brought towards source charge through a potential difference of 1 volt, during that process whatever amount of work is done, that work done is the potential energy, which is nothing but 1 joule. There is another unit of potential energy which is to be called as 1 electron volt. This 1 electron volt is equal to 1.6 into 10 raised to minus 19 joule. Now what this energy is this? This 1 electron volt is the potential energy of electron. So the 1 electron volt is the kinetic energy of an electron when that electron will be moving through a potential difference of 1 volt. Then that is nothing but the another unit of potential energy. Now from this potential energy, now we are going to switch over the concept of electric potential. So now from potential energy, we will switch to the concept of electric potential. Now how you have this potential energy? So I can say potential energy UR can be written as 1 upon 4 pi epsilon naught Q1 Q2 upon R. Same equation now I can say this potential energy UR can be written as 1 upon 4 pi epsilon naught Q1 R into Q2. Or same thing I can write down as a 1 upon 4 pi epsilon naught Q2 R into Q1. Means I can write down this is nothing but now this term 1 upon 4 pi epsilon naught Q1 upon R is a potential V1 of charge Q1 at a distance of R into Q2. It is equal to second term written 1 upon 4 pi epsilon naught Q2 upon R is a potential of second charge of distance R multiplied by Q1. That is nothing but as your potential energy. So this V1R and V2R are the electric potential of charge Q1 and Q2 at a distance of, now I can say that at a distance of R1 and R2 respectively. And therefore now I can say that, now I am getting the formula, UR means potential energy is equal to electric potential into Q2. Q2 is nothing but charge. Means in short, now I can say that this V1R can be written as it is equal to UR upon Q2, or it is also written as UR upon Q1. So this electric potential is nothing but as a potential energy per unit charge. So that is nothing but your definition of electric potential. So electric potential is also potential energy per unit charge. And now we are switch over to the another concept, which is nothing but the relation between our next concept, which is nothing but as a electric potential and electric intensity. So this electric intensity and electric potential. Now we can relate that electric potential and electric intensity. For that purpose, what we can say that, let's consider there is a charge Q in the medium at point O, and there is another charge Q0 at point M, which is at a distance of x. Now I want to displace this Q0 charge from M point to N point through a certain displacement as a dx. So whenever this Q0 charge will get displaced towards source charge Q through a distance dx, at that time small work is done. That work done is equal to nothing but minus F into dx. Minus sign indicate that direction of force and direction of displacement, they are opposite to each other. Now instead of this force, now we can use the 11th standard electric intensity definition. Electric intensity E is equal to F upon QC. So now from this formula I can say that F can be written as E into QC. So that value I can substitute here. So instead of F, I will substitute E into Q0 into dx. Q0 is a charge. Now if I am saying that this Q0 charge is a unit positive charge means it is equal to 1. So at that time your work done dW is equal to minus E into dx. And this work done is nothing but the electric potential. So instead of this dW, I can substitute as a dV, and this dV is equal to minus E into dx. So now I can say that now I will get a relation between, now I'll write this step, I'll write down intensity E is equal to minus dV upon dx. dV upon dx, this quantity is called as a potential gradient. Means now I can say that electric intensity is equal to negative of potential gradient, and that is called as a relation between intensity and electric potential. Now this electric potential is dV by dx. dV means change in potential, dx means change in displacement. So the unit of this potential gradient, this is nothing but I am going to call it as minus potential gradient. Unit of this potential gradient, first I will say formula for potential gradient is dV upon dx. So unit is nothing but volt per meter. So remember this formula carefully. Electric intensity is equal to minus dV by dx, which is equal to minus potential gradient. Thank you.